Another motif that we're going to see a lot is called the loss of a leaving group. And a leaving group is a group that leaves. Right, and that's kind of duh, right? It's called a leaving group. Sometimes you'll be capitalized LG. And so think about a leaving group. In order to kick out a part of a molecule and make it leave, it has to be stable enough by itself, right? If it can't survive by itself, it's not going to leave. So must be stable by itself. So some examples of some good leaving groups are halides. So maybe like a bromide, an iodide, or a chloride, right? All of these are relatively stable by themselves, so they make good leaving groups. Another common leaving group we'll see is water, H2O. Water is obviously very stable, and so it can act as a good leaving group by itself. So for example, we could have go from the left to the right. So think about the differences here. Here we broke this CBr bond, and if you think about where the electrons went, they went to the bromide, and so that mechanism would look something like that. Oftentimes we'll see a water molecule, right? So this oxygen now has 3 bonds, so it has a positive formal charge, and it can be a good leaving group. So we can go from the left to the right. If you think about what bonds are breaking, we're going to need to kick these electrons from this bond onto this oxygen to form our final compound. And of course, we can combo some of our leaving group stuff with some of our nucleophilic attacks. So for example, maybe you have this bromine complex, and then you have a hydroxide, right? We have a nucleophile here. We have our electrophile here. And so we're thinking we could do some kind of nucleophilic attack on this carbon. Of course, we can't break the octet rule, so we could also have this bromine leave. It's a good leaving group, and so that's okay to get our final products. Again, I don't expect you to be able to predict this stuff yet. We'll go in much more depth. This is just kind of an introduction. And these mechanisms can be even more complicated. So this is a cool one out of one of the books. So we start off with the molecule on the left, and then we end up with this molecule on the right. Plus a chloride. So go ahead, pause the video, try to identify which bonds form, which bonds break, and then try to figure out the mechanism. So one thing we can notice is that we have, there should be a positive charge here, we have this NO bond right here, and we have a double bond right here. And so we have to somehow form this bond. If we're thinking about where the electrons could come from, they could probably come from this negatively charged oxygen towards the more positively charged nitrogen. So there's a good guess right there. If we think about this other side, we have a single N carbon bond. Here we have a double bond, so that's got to get switched up. And then we have this single double bond, and then these 2 pi bonds as well. And then, of course, our chlorine must leave, right? And so we can think, okay, chlorine's got to leave, so we can go ahead, draw those arrows right there, and then just think about how we can interconnect these 2. So one idea is to kick this bond right here, kick that bond right there, and then we'll end up with our final product. This is definitely a more advanced problem. I wouldn't expect you to be able to do this just yet, but it's just a good example. And you can actually just do this in 2 steps. One step, you could draw the resonance structure of this, and then just kick out the chlorine as well. So go ahead, try to do it that way instead. And in the end, right, we learned nucleophilic attack, and now we're thinking about loss of leaving groups.